Right, so I'm going to record a video of us going through question 5. It's an interesting question that raises a few important points. It's a little bit of a quirky question because of the maximum bit in parts 2 and 3. So I thought it was important you see how this one is done. So let's get straight into it. A particle p starting from rest moves so that its velocity v meters per second at time t seconds is v equals 12t squared minus 4t cubed. Find the distance the particle travels before next coming to rest. So it starts from rest, it travels with that velocity, and at some point in the future it comes to rest again. And we've got to find how far it travels in that time. So, what do we know about something at rest? Well, when something's at rest, it hasn't got any velocity. So I'm going to write at rest v equals 0. Okay, so that's going to create us an equation to solve. I'm going to substitute in 0 for v, and we get this equation. Okay, we can solve this because it equals 0, and the thing to do is factorize it, as hopefully you realize. The highest common factor here is 4t squared. And when we remove 4t squared from this term, we get left with 3, and when we remove it from this term, we get left with t. So I've got this equation, which tells me that either 4t squared equals 0, and that implies t is 0, or 3 minus t equals 0, and that implies t equals 3. Okay, well, we knew that at 0 seconds it was at rest because it said it started from rest, so that's reassuring. And then we get this 3 seconds. So it next comes to rest after 3 seconds. The question wants the distance travelled in that time. Well, we've got a velocity equation and we're trying to find a distance travelled, so this is one of these integration questions. We need to integrate between 3 and 0, and we need to integrate the velocity function there. Okay, so this will tell us how far it travels in that time. Okay, so this is a definite integral. There's no need for the plus c in this situation because it would cancel off when you do the subtracting. If you're not sure what I mean by that, then do please ask me and I'll try and explain that some other way. So now we're going to integrate it. We need to raise the power by 1, so squared will become cubed. I'm going to leave the 12 as it is, and we divide by the new power, which is 3. With this one, raise the power by 1, it will become 4, divide by the new power, and we get there. Okay, and a lot of this will simplify down. Those 4's will cancel off rather nicely, and this 3 and this 12 will cancel off to leave another 4. So it's 4t cubed minus t to the 4. And we've got to put 3 and 0 in. Okay. When we put 3 in, it's 4 lots of 3 cubed. Okay, 4 lots of 3 cubed. Well, 3 cubed is 27, and 4 27s are 8 is 108. And here we need to do 3 to the power of 4. Okay, well, I happen to know that 3 to the power of 4 is 81, so we get that there. And when we put 0 into this, well, this will be 4 lots of 0 cubed, and this will be 0 to the power of 4. It's just going to be 0 minus 0. You'll soon realise after a while that when you put 0 into anything that you've integrated, you'll always get 0. So basically the answer is whatever this bracket turns out to be. And if you have a look at this, that bracket is going to turn out to be 27. Okay, so the answer will be 27 meters. Okay, must have a unit. Just check it is meters. Yeah, meters per second. Okay, so that's the first part of that question. We can't see all of it, but we'll leave it there. Let's look at part 2. Just move that over a tad. Okay, find the maximum acceleration in the first 2 seconds of motion. Now then, you might see the word maximum and think, oh, maximum, that's differentiation. I need to find a maximum. But there isn't necessarily a turning point in that first 2 seconds of motion. It might just be that the acceleration just goes up and up and up for the whole 2 seconds. Okay, in which case the maximum acceleration would be the one at 2 seconds. If it does have a sort of turning point, then sure, differentiating will find the maximum acceleration. But because we don't know, we need to investigate really, and the best thing to do is sketch an acceleration time graph. Okay, so what I want to do is work out what the acceleration is. Okay, that's the way I'm going to do this. So let's work out the acceleration function. How do we get acceleration from velocity? We differentiate it. So a equals dv dt. Alright, so I'm going to differentiate that velocity function that they've given us in the question. If you differentiate 12t squared, you get 24t. If you differentiate minus 4t cubed, you get minus 12t squared. So here, look, is our acceleration function. I'm going to try and sketch this for 2 seconds. So t, a, I'm doing an acceleration time graph. So, well, it's a quadratic because the highest power is squared. Let's just move this over a bit. It's a quadratic, and it's an upside down quadratic because we've got the minus squared, so it's going to be an N shape. Okay, it's tempting to think it goes through 0 and 2, and it might do. Let's just find out. When t is 0, a would be 0, so it does actually go through there. If t is 2, do we get 0? Well, if you put 0 into that, sorry, 2 into that, you will see that you do get 0. So it does actually do this shape. Okay, so that's what the acceleration looks like for the first 2 seconds. And we've got to find the maximum acceleration. Well, as there's a turning point, we could differentiate, but we could also just use our knowledge of quadratics. This quadratic is symmetrical, so unsurprisingly, that bit there will be when t is 1. So the maximum acceleration is when t is 1. Max a at t equals 1. That hasn't answered the question, that's just worked out when you get the maximum acceleration. We've actually got to plot 1 into here to work it out. So I'm going to write a max equals 24 times 1 minus 12 times 1 squared. And you'll hopefully see that that's going to turn out to be 24 minus 12. So it's 12 meters per second squared. There is your maximum acceleration in the first 2 seconds. Okay, now then, I haven't got much space for part 3, but I think I've possibly got enough. Find the maximum speed attained in the first 3 seconds of motion. The maximum speed attained. Well, we'll be going back to the v in the question. Okay, so look back up at the question, and we've got the formula or function for v, and we want to know when that is biggest in the first 3 seconds. And I'm going to use this to help me, okay, because if you look at this, for the first 2 seconds all the accelerations are positive. They're all positive accelerations. Even here, look, just before 2 seconds, if you read across, that is a positive number on the acceleration. So all of this, because it's above the t-axis, has positive accelerations. Only after 2 seconds do we get a negative acceleration. And what does a negative acceleration do? It tries to make you go in the opposite direction that you're travelling in. So it's going to make you slow down, basically. Okay, yeah, sorry, I had to think about that for a minute there. It's going to make you slow down. So you are going to have your maximum speed at 2 seconds, because you start from rest, positive acceleration, positive acceleration, positive acceleration, so you're gaining speed all the time, still positive, still positive, still positive, so you're still gaining speed just at a lower rate, still positive, still positive, still positive, so still gaining speed until you get to here where you get negative acceleration, so you're going to start losing speed or losing velocity. Okay, so you're going to have maximum velocity when t equals 2. And if you were worried about what to write, you can use from AT graph, acceleration time graph. So let's put 2 into that velocity function in the question. And we get this. So it's 12 times 4, that's 48, minus 4 lots of 8. What? Which is also, oh, hang on, 4 8 to 32. Bad maths, I thought 4 8s were 48 for a minute there. 4 8 to 32, so we end up with 16 meters per second. Okay, I have not checked those answers, so if you think any of them are incorrect, let me know. I should say that's V max. I'm not really going to be able to fit that on there. So there are the answers to question 5. I hope you've enjoyed that. Please do ask me any questions on MS Teams or email if you need to.